everyone, this is week 7, Soil 360, part 1. In this section, we're going to talk about Entisols and Inceptisols, two soil orders that are pretty important for wildland soils. Our learning outcomes for this material are to describe the settings, like where they occur geographically, the important pedogenic processes, if any, land uses, and other important differentiating characteristics used for Entisols and Inceptisols. And we'll go through all these learning outcomes for all the soil orders that we have. This week we're doing Entisols and Inceptisols. In lecture, I'm going to talk about 9 or more differentiae used at the family level for mineral soils and soil taxonomy. And we're going to talk about the different control sections for family differentiae, and we will practice classifying soils to the family level. But in this PowerPoint, we're going to mostly talk about the orders themselves. So entisols are covered in Chapter 11 of Buell et al. And also in Chapter 8 of the Keys. So I encourage you to have those, to read Chapter 11 before you do the quiz. It's some pretty good writing. And also to reference Chapter 8 in the Keys to Soil Taxonomy. As many of you know already, entisols, the formative element here is ent, have no profile development to speak of, and they're occurring because they're either very young, they're wet, they're very dry, or they're underlain by very resistant material that hasn't really developed into much of a soil profile. They can also be, in terms of being young, entisols could form in very unstable landscapes like very steep and rocky slopes where erosion and colluvial action just continually peel off loosened material. The authors of Buell et al. Make the point that soil forming processes may be occurring, but not to the extent that horizon differentiation has occurred to any extent. Now let's look at a map that NRCS came up with a couple of years ago that shows the settings of where entisols occur. I want to point out first off that in the 12th edition of Soil Taxonomy, Keys to Soil Taxonomy, the arents are not included in this version of the keys, so we won't talk about arents. Those are where soil horizons were broken up by plowing and human interaction. Rather, the one that we will add here to dominant suborders would be wascents. Wascents are a very new idea where the profile is saturated or has a positive soil water potential for 21 or more days out of each month. So those are a new suborder. I'd like to point out on this map that the aquants with aquic moisture regimes are occurring along the Mississippi River Valley. There's some in Florida. There's some on the southeastern coastal plain. These are very localized around the country. The fluvents are characterized by old floodplains. They tend to have an irregular distribution of carbon with depth, and we're going to look at the keys in just a moment here. The saments, sam means sandy, and you see a very saments area of saments here. These are the sandhills of Nebraska, but there are other localized regions of sandy material that go into saments. Orthants are kind of the other soils. These would, as you can see, they're in a lot of the mountain ranges, the Mogollon Rim here, the Four Corners area, the Rockies, and so forth. A lot of these are going to be just some of the steep and rocky ones. I wanted to take a moment here also to highlight Chapter 8, where this is the key to the entisols in Keys to Soil Taxonomy. They talk about wascents, entisols that have a positive water potential at the soil surface for 21, it wasn't 21 days, it was 21 hours of each day and all year. So those are underwater soils basically. Aquants are the ones that have saturated conditions, aquic conditions, or permanent saturation. You can read about that. Saments are other entisols that have less than 35% by volume rock fragments and a texture class of loamy fine sand or coarser in all layers. So this one is very sandy, and that's why we had those sand subclasses. We have to pay attention to those. Fluvents are ones, they exclude some things, but in general they have a low slope less than 25%, and they have irregular distributions of carbon uh, throughout the profile, and they're usually not very cold types of soils. I'm going to try to turn the page now here, and it goes into aquants as the last suborder. So we have wasants, aquants, saments, fluvents, and then orthents. And then from there they jump into a key that takes you to more detail and gets you into the great groups. Okay. Okay, entisols, when you talk about use and management, it really depends. If you may have very arid, rocky, or steep entisols like many of the orthents, or on the other hand, you could have very rich alluvial soils. And the classic example that they give in the textbook is the Nile River. Before they built the Aswan Dam, rich, fertile soil came down and was deposited along the banks of the Nile River through a process of cumulation, and these served as very useful agricultural soils. In California, down in the Imperial and Coachella Valley, we have Torrey fluvents. Torrey is another word that means aeritic moisture regime, and also Torrey saments, and they can be very productive when irrigation is added to these soils. So that's a quick and dirty, haha, quick and dirty overview of entisols. We're going to move on here in just a second to inceptisols. Now let's transition to inceptisols. These are covered in Chapter 14 of Buell et al. And also Chapter 11 in the Keys. Inceptisols, as a general rule, have a weakly developed soil profile, and they're kind of one step beyond the entisols. They do have overall more leaching that has occurred, and the cambic horizon is possible here. It's also important to look at page 40 in the Keys because some other diagnostic subsurface horizons can come into play here. If we look at the settings and the dominant suborders of inceptisols, the one that is not included on this list is the gelept. Okay, so if you were to look at the Keys, gelept would be in there, but then there are also these other 6 different, I take it back. They no longer include anthrepts in our Keys to Soil Taxonomy, the 12th edition. So if you might want to strike out anthrepts and forget about those, and then put in gelepts as another kind. So if you have gelepts and cryepts, what are those determined? What's the basis for those? Gelepts and cryepts. If you said that's a temperature regime, that's correct. And you can see that cryepts here occur up in the high mountains of the Rockies and the Cascades. On the other hand, we also have aquepts, eudepts, ustepts, and xerepts. So what's the basis here for breaking it down into a suborder? Here, if you answered soil moisture regime, you would be correct. And so eudepts occur up and down the Appalachians in parts of the upper Midwest here, ustepts throughout some of the Great Plains states, cryepts we talked about already. And then there are some eudepts in forested soils up here along the north coast and coastal Oregon, and we have a lot of xerepts in California as well. So the basis for division into suborders would be both temperature regime and moisture regime. In terms of use of inceptisols, use and management, they are highly variable depending on context, like the entisols, but there is one special group that they talk about in Buell et al., the sulfoquents, which are inundated soils where if they're drained and they have material that turns to sulfuric acid, they can be very low pH and cannot support plant growth. I'd like to look for just a minute here at the Keys to Soil Taxonomy and show you how they break out into inceptisols. We have aquepts, which have probably, actually this one is a little bit tricky because they talk about Histic epipedons here, sulfuric horizons, and then they talk about different kinds of redox conditions, or within 50 centimeters of the mineral soil surface, enough active ferrous iron, which is the reduced iron, to give a positive reaction to alpha-alpha dipyridyl. So this is some discussion about glade soils. Or the other place that you can get into aqueps is where you have an exchangeable sodium percentage of 15 or more, and or a sodium absorption ratio, SAR, of 13 or more, and half or more of the soil volume. So this is one that might pop up a little bit later in our semester. I'm pointing it out right here. They're not coming out and saying that that's a salic or a natric horizon or anything like that, but that is one way that you can get into aqueps. The gelic soil temperature regime, that would be a permafrost type situation. Cryic soil temperature regime would be something between 0 and 8 degrees C with cold summers. And then they move into ustic moisture regimes, xeric moisture regimes, and other inceptisols, which go to UDIPs. And it turns out, what's the other soil moisture regime that we're not covering here? That other soil moisture regime would be an aeritic moisture regime, but the way that the keys to soil taxonomy are arranged, some of these soils would come out before they would get to inceptisols. I'm going to stop this and turn a page and talk about that a little bit more. So here I've switched back in keys to soil taxonomy to page 38. I'll pause so you can turn back to page 38 as well. If we look at what comes out first, it's gelisols, then histosols with their organic soil materials. Sorry, part of this is cut off at the bottom. The next order that is here in the keys to soil taxonomy are, if I can get the page to turn, I'm getting the page to turn. The next order would be spodosols, where they're talking about spodic materials here. They're talking about the possibility of albic. Then they talk about andisols, and then they talk about oxasols, and then vertisols, and then iridosols. So iridosols comes out with an aeritic soil moisture regime and an ochric epipedon and a cambic horizon or other kinds of subsurface diagnostic horizons. So pretty much the soils that have an aeritic moisture regime are kind of being and have any kind of soil development, including cambic, are being pulled out at this point. If we go on to the next page, it goes into ultisols, mollisols, alphasols, and then here is the start. I'm going to flip the page and then go back. This is the start of inceptisols. So in inceptisols, they're saying, okay, it could have a cambic or could have a calcic, petrocalcic, phragic, oxic, sombric, a lot of different things. But my point here is the aeritic ones were pointed out, were pulled out of this beforehand. One other thing that I should mention briefly too is that andisols used to be in inceptisols. They were andepts. So in some of the older literature, if you had parent material that had these special andic soil properties, although they didn't have that very well defined back then, these were andepts before andisols was set aside as its own soil order. Likewise, we used to have cryepts, and those were soils that are now placed into the gelisols or the permafrost soils. So some changes have been made to inceptisols, but overall they don't have any main consistent theme. They're just a little bit more developed than the entisols are.